Okay, we're going to look at what's called simple harmonic motion. So basically, harmonic motion is something that's periodic, so it can be modeled by what are called sinusoids, or the graphs of sine and cosine. So for example, I could take this, and this is a pendulum, that can be described by periodic motion or a sine or cosine graph. Okay, so an example would be the pendulum swimming like I just had, or we could take something bouncing like a spring going up and down, up and down. A mass bobbing would be an example of something on a spring. Okay, so note, for most of these examples, we do not have to worry about opposing forces such as friction or buoyancy. Okay, so let's look at an example here. I have a mass that's going to be bobbing, and when it's at rest, it'd be located right here. If you pull and you start with you're going to start with the weight pulled stretched all the way out. When you let go of it, it's going to spring up to here, and then when it's at rest and you're not pulling it, it's going to hang out right here. So we're going to say that this can be modeled by the graph 5 cosine of t. So let's get a graph of 5 cosine of t. So that means at t equals 0, it's pulled up 5 units. Okay, and it means that it's going to go one complete cycle. So we know that the cosine graph comes down and is here at pi. So it's going to be pi over 2. So we're going to come down, and then we're going to go back up like such. Okay, so now we want to start to analyze this graph. You're going to be asked a series of questions about this. So the first question is what is the velocity? Well, the velocity we know is the first derivative. So velocity would be s of t is equal to 5 times the cosine t. The derivative of cosine is negative sine, so it'd be negative 5 sine of t. Okay? So the next question is, what is acceleration? And acceleration is going to be the first derivative of, or it's actually second derivative. So acceleration is going to be, take this, and then it's negative 5 cosine of t. Okay, so now we have those functions. Now we can start to analyze some graphs and what it can tell us about it. So what is the velocity? We can say from velocity, we can graph the velocity function and say that's negative 5 sine of t. So sine of t is going to start here, and it's going to go from 0 to 2 pi, and it's going to go up and back down, something like that, and it's going to go from negative 5 to 5. We can say that the greatest magnitude equals 5, and we can say that it's at rest at 0. Okay, what would the speed graph look like? Well, the speed is going to be the absolute value of velocity. Okay, so the absolute value of velocity is going to be absolute value of 5 is 5, and then absolute value of sine of t. So I'm basically going to take the velocity graph and make an absolute value function out of it. So I'm going to end up, my speed graph would look like this. Go boom, 2 pieces. This would be pi, this would be 2 pi. Okay, and all right, what does the acceleration graph look like then? Well, acceleration graph is negative 5 cosine t. That's going to look like the exact opposite of my position graph. So negative 5 cosine of t is going to be this graph right here flipped. So it's going to be here and at pi and at 2 pi. Okay, so it's going to be up here and down here, and graph's going to go like this. Okay, so it's important to realize that's the exact opposite of your position graph.